Good morning, Algebra 1 students. Let's take a look today at lesson 95. If you'd like to turn to your books, you can. It's on 395, but it's not really necessary because actually what I've done for you today is we're going to actually walk through the pages of the lesson. So I have those here ready for you. So you don't need to have your book there, but if you're a book person and want to have it there to flip through, that's fine. Anyway, let's go ahead and get started on this. So we're going to talk today about different kinds of graphs other than the graphs we've been graphing. What we have been graphing are linear functions or linear equations. Today we're going to look at non-linear functions and non-linear equations. We are simply going to just learn how to recognize these various shapes of nonlinear functions. So let's just be reminded of what we do know. So we've been solving and graphing linear equations that end up in this form, mx plus b. So we could have f of x is equal to x plus 1. This is a linear equation. G of x equals 2x minus 1. Another linear equation. And the last example that we'll put down here is 1/2 x minus 1/4. Those are all linear equations. Now, what makes them linear is that they are first-degree equations. In other words, I'm referring to the exponents. Also, always remember the word linear implies a line. And you can see that right in its word right there. Right inside there is the word line. So when these all get graphed on a coordinate plane, they're always going to end up looking like a line, okay, wherever their points end up. Also, remember, don't be thrown by the functions over here. Remember that those all replace x, so it's like y equals mx plus b, okay? Always remember that. We have our input and we have our output, and the reason that I want to make sure we understand that is we're going to see later in the lesson. I just don't want you to get thrown by seeing the f of x or g of x or whatever. That's just replacing y. So if I were to do a table, for example, and we've done these before, even if I just take this simple equation up here, x plus 1, and we put it as a y equals x plus 1, whatever I put in for x is going to spit out my output, right? So let's just see what would happen here as an example. Okay, so I put in a -1 for x, it spits out a 0 for y. I put in a 0 for x, it spits out a 1 for y, and so forth. Okay, so output and input, very important. Just keep that in mind as we get through the lesson today. All right, so let's go ahead and look at the first page of our lesson. Actually, it's the second page in your book. Here's a special kind of a graph. This is called a parabola. And a parabola is considered something called a quadratic function or a quadratic equation. Okay, parabola is what that will end up graphing. So if you have a second degree equation, remember a line is a first degree equation, a parabola is a second degree equation. And it's kind of cool because if you think about it, a first degree equation is a straight line. So it only has one direction, right? It's either going up or it's going down, but it's one direction. Whereas a parabola has two directions, and you can see here it's going up over here, and then actually let's have it come down here. It's coming down and then it's going to go up. So it has two directions. Now they can be sitting in different places in the graph, as you see over here. It's just slid over some. Here it's slid down, so they're translated. Okay, and this was just completely flipped. Okay, so parabolas, and you notice if you look up here, I'm circling all these little 2's up here in the description paragraph above. Hold on, my little, my app is acting funny. Can't seem to get something off of it. Hold on. Okay, now this may work. Alrighty. So I'm circling all these little 2's up here because I want you to see these are second degree equations. So when you think about it, they're going to have two directions, and the parabola does. Now look at their input and output table here. Okay, so they made this little table where whatever they put in for x is going to spit out something for y, okay? So in this case, your equation would actually be I'm sorry, let's turn that around. I just want to write this down here. So for example, if you had f of x equals x squared, this is acting as right, so whatever I put in for x over here, y happens to be x squared, so we have to just put that in there. Okay, but the point is, don't let that throw you. Just remember that f of x, I think I wrote that backwards, sorry guys. But anyway, the point is, you have your table of values here that whatever you put in for x is going to spit out the solution. So when you get these plotted, all these points on your plot, on your graph, they're going to turn out to look like that, and that's a parabola. Let's look at a cubic function. Now the word cubic already implies something, doesn't it? The word cubic implies a third degree equation. The highest degree on your equation, remember, is the type of equation you have. So I have a third degree equation here. Even though I have an exponent of 2 and an exponent of 1, the highest degree in my equation indicates what kind of an equation that is. This is a third degree because the highest degree in the equation is the 3. Okay, cubic functions. So what do they look like? So if I had a table and I put if I used any one of these equations here and I set up a table and found out what my results were, it's going to graph a graph that looks like this. Okay, now notice a cubic function, a third degree function, has 3 movements. In this case, it's going up, it's taking a right, and it's going back up. 3 movements. This one, let's look at it this way. Same thing. It's coming up, making a turn, and coming down. Or it could go down and make the turn. Either way, you see 3 movements in the graph. Okay, that is a cubic function. Just positioned differently depending upon how your equation turns out when you plug your values into the equation. Okay, here's 2 more. They're just translated. They're just in different locations. All right, let's look at square root functions. Square root functions, here's the type of equation you're looking at solving. Has a square root in there. If we did a table, which is very tedious work, but you could do that. If you took that equation and you plugged in values for x, you'd figure out what x squared is going to become. And when you graph that, look at all these values over here, placed down on all of these graphs. Okay, so it's just a trail. It's not a straight line, is it? Because you can see where the curving was right here. Okay, so it's heading out into a direction that could be translated over, depending upon what your equation is. It could be starting up here on the y-axis as 2, or it could be heading in a downward position. It's a curved line, okay? That is the square root function. So basically, we're just going to learn today to recognize these. We're not even going to solve any. We're not going to graph any. We just want to know what types of graphs they are when we see them. And these are absolute value functions down here. So again, if I had an equation that looked like this, f of x equals the absolute value of x, whatever I put in for x right here, remember this is like y. Okay, so whatever I put in for x, so look here, if I put, I'm going to go ahead and change that to a y just so it makes it easier for us. Let's put a -3 in here. What am I going to get? Y is equal to 3. So right here's that. Okay, let's go put in 2. If I put in y is equal to the absolute value of 2, well then y is equal to 2 because the absolute value is always positive, right? So right here's that point. So when x is 2, y is 2. When the input's 2, the output's 2, however you want to say that. But here's how those will turn out. And I could keep going and prove to you about all these points, but you're just going to take my word at this point. Okay, because I've already shown you 2 examples off to the left there. All right, so when these points get plotted, that was a lot of P words there. When those points get plotted on the graph, this is what they turn out to look like. It almost looks like the big letter V. It can be this way. It's making 2 directional changes here. Again, here, here. Okay, they're just positioned differently on the graph. Here's one that's upside down. Okay, so those are just that somehow your values are turning out to head in those directions. Okay, so those are considered your absolute value functions. So just be able to recognize those. Now let's look down here at 95.1 at the very bottom. I'm not going to scroll up because I think the answers are right below there. Yeah, we'll just keep it right here. All right, so let's look at this. So the graph of a quadratic function could resemble which of the following graphs? So the quadratic function, remember, is a second degree equation. Second degree equation is going to be going in two directions, right? Not the absolute value. Remember, the absolute value comes to a point and changes, whereas a quadratic equation or a second degree equation has a curve as it changes. So it looks like letter B. That's, what do we call that? That's the parabola. Okay, let's go down here. I'm going to scroll very slowly so we don't give away any answers. All right, let's look at these. So given the equations of the following functions, let's look at all these. So I have a third degree equation. I have an absolute value here. I have a square root, and I have a second degree equation. So let's see if we can match these up. All right, I'm just going to write on top of each one of those which ones they are. So remember, we said a second degree equation. Let's look at A, second degree equation. This is a parabola. So this one has to be right here because that is a second degree equation. Here, remember, we have three movements. We're coming up, we're turning, and we're going up. That is a third degree equation. So that would be this one right here. So we'll put B up here. See what else we have here. The absolute value, let's look at this one. Remember, the absolute value is somewhat, it has two movements, so it's like the parabola, except that it has a very specific point at where it changes direction. Okay, so that is your absolute value, which is going to be C. Absolute value function. And then, of course, the last one leaves to be the last one that's available to us, and this is your square root one. Remember, it starts at a point, it starts to curve, and then it continues on out there, but you see that it's actually at going at a curving movement the entire time. So D is going to be our square root. All right, let's look at, let's see what this one is. Okay, 95.3. Same deal. We are going to look at, there we go. We're going to match these up as well. So let's take a look now that they give you the shapes. Let's find the equations. All right, this is a parabola, two directions, right? With a nice curve right here. That's a parabola. Second degree equation right here. So this one will be A. This one has three movements. It's coming down, it takes a turn, and it continues down. Third degree equation. Letter B goes right here. The square root, remember the square root? Square root is the one that starts at a point, starts to curve, and then continues on in a curving motion. So that is D because we see the square root right here. And then the last one is the absolute value. The absolute value has two directions as well, coming down, but it stops at a very specific point right here, and then it turns and goes in the opposite direction exactly the same way, which makes sense. Because your absolute values, whatever you put in, the absolute value is going to be the positive number of that. Whether your absolute value that goes in, like for example, if I put absolute value of -2 is 2. The absolute value of 2 is 2. The absolute value of -3 is 3. The absolute value of 3 is 3. That's why you see each one of these. Oops, that's a positive there. That's why you see them just going in opposite directions, but their points are like right across from each other. Okay, so the absolute value is this one here, and that is C. All right, now on your packet, and I did not upload the packet to this particular Notability, which is my app. I didn't put it onto this particular form that I created. But if you want to look at your packet really quickly without me showing it here, you have a nice variety here shown of the examples that you need to understand. I just want to go through them in the book because I thought they did a really great job of explaining those. Also, turn the page in your packet. Let's look at those graphs up there. There's, let's see, almost 16 graphs right there, just different kinds. And some of those we're not even going to look at. And we're not going to worry about doing much more than being able to just recognize these graphs, because later, you're going to learn how to actually work with them. But right now, the most important thing is that we understand and recognize that not every graph is a straight line. As you can see, there's 4 more that we learned just today, and there will be several others in time that you will see as well. All right, so let's look at our practice set here. We have these equations or functions, okay, and they give us the 4 shapes to match those up to. So go ahead, if you want to pause the video, let's go ahead and see which one goes to which one. Write those out, and if you want to move on to B and try those as well, you can come back and check your answers with me, and if you get them right, perfect, you can move on. Otherwise, maybe you want to just stay tuned to see why they are what they are. Alrighty, go ahead and pause if you'd like and work those out. Okay, so I'm going to be looking at all of these individually. Number 1, right up here's where my functions are. I need to match those to 1, 2, 3, and 4 below. This is in your practice set here. Okay, so the first equation that's given to us up here is a second-degree equation. So let's go find the graph below. It has 2 directions, and we know that's a parabola. So this one is going to be number 4 is a parabola, and this is going to go with f of x equals x squared plus 2. Let's look at this next one up here. G of x equals negative the absolute value of x minus 1. So anytime you see an absolute value sign in there, we know that we're looking at this one that also has a change in direction, but at a very specific point, and then continues on in the other direction the same way as the other side of your graph. So number 3 is going to be the absolute value function up there, which looks like this. The third one up here is a third-degree equation. Look at that. So we know it's a cubic function, isn't it? Cubic function has 3 different movements. So we're heading up, we take a turn, and we're heading up. Okay, remember, they can also look like this. They can go down this way. Three movements. But this one here is going to be the third-degree cubic function. And then the last one, of course, has to be the square root. But we remember the square root function starts at a point, starts to curve, and continues on and on. Okay, so this one is going to be the function that starts with k of x equals the square root of x. Okay, so recognizing what they look like on a graph. Now here they give us the graphs. Let's see if we can determine what those are. And we have to match those to these down here, down below. Okay, so let's do that. So let's look at this first one is a parabola. That's going to be coming from a second-degree equation. So number 1, I'm just going to put number 1 down at the bottom here. Number 1 is going to be this one right here because it's a second-degree equation. And this has 2 movements. Number 1 has 2 movements. Let's look at number 2. Right here, remember we start at a point and it starts to curve and head on and on forever. And when that happens, we're looking at what kind? That's a square root, isn't it? So that one's going to be number 2. It's going to go right there. The third one, this is when we have 2 movements, okay, but it stops at a specific point before it changes direction. Okay, that's going to be your absolute value. So 3 is going to go right here. And then, of course, the last one is a third-degree equation, which the graph should be looking at 3 movements here. So it's coming down, it's turning right, and it's heading back down. So number 4 will go right here. And I hope this all makes sense to you. These are kind of fun, even knowing that there's different graphs. You know, by the way, you probably think, well, why does anybody ever use those? But believe it or not, these nonlinear functions are used not only in higher level math courses, which you're going to continue to see, but they're also frequently used in some types of businesses and science and computer science. And a lot of engineering. So if you're going into any one of those fields, you will also need to understand how these graphs work in real life situations. All right, guys, enjoy the day, have fun with your lesson, and I will see you all next week. Take care.